Here we're asked to determine if the given side lengths make a right triangle. So everything that we know that has to do with a right triangle, we always relate back to the Pythagorean theorem, which is a squared plus b squared equals c squared. In this situation, if we're given three lengths, we can decide if it's a right triangle if they fit into this equation and make this equation true. So in this case here, determine the side lengths, which ones would be the legs and which would be the hypotenuse. Now, remember, with a right triangle, the hypotenuse always has to be the longest of the three sides. So in this case here, we're just going to compare them real quick to figure out which one's the longest. So we know 7 is not going to be the longest. 10 might be the longest. We need to figure out what the square root of 51 is close to. Well, I know that the square root of 7, or the square root of 49 is 7. So it's just a little bit more than 49. So I know that this is just going to be a little bit more than 7. So I know it's going to be definitely less than 10. So my hypotenuse, I know, is going to be 10 if this is a right triangle. So now, if I were to kind of put this on here, I could say that this is 7, this is the square root of 51, and our hypotenuse is 10. But we don't know for sure yet until we take these numbers and plug them into the Pythagorean theorem. I'm going to say 7 is A, square root of 51 is B, and I know that the hypotenuse has to be 10. So now I plug this in and I say 7 squared plus square root of 51 squared equals 10 squared. Now I just have to find each of these values. I know 7 squared is 49. I know a square root squared just cancels these out and gives me the number on the inside, so that's going to be 51, and 10 squared is 100. 49 plus 51 is 100, and since this creates a true equation, I know that these three values do create a right triangle. If this was not equal, if I got a number on the left that was not the same as the number on the right, that would tell me it is not a right triangle. But for this one, it is, and we're good to go.